Hey, hello everyone. Can you hear me clearly?
When can we start? Can we start now?
Yeah, I think I shown already for your Discord. Can you turn on your mic? So like if we see like if there are any issue.
Oh wait, sorry, I cannot hear you.
Let me know if you can hear me, guys.
Hey, yeah, we can hear you.
Perfect.
But I think it's a bit like can you turn it louder?
Can you hear me now?
Yeah, no, I'm not talking about you. Yeah, I'm talking about sound.
How about now?
Yeah, it's still a bit quite low.
Trying to find my settings on Discord for the sound. A different microphone.
Okay.
Is this better?
It's better now.
All right, okay.
Okay, we start now.
Give me 1 minute.
A few more minutes. Okay.
1 minute. Yeah. Let's get started. Let me send it.
Okay. But first, Seun, is that your name? I just want to make sure I don't butcher your name.
Yeah, Sean is fine.
Sean, right? Okay.
Yeah.
Okay, let's start our call today. Hey guys, OpenGuild is thrilled to be back with another community call. Our live streaming call is brought to you by OpenGuild and Polkadot Insider. So OpenGuild is an open community driven by Web3 builders elevating the Polkadot ecosystem in Southeast Asia. At OpenGuild, we learn and share our tech experience, and we also create a great space for all the devs, especially Polkadot lovers, to connect and contribute. Follow us on Discord and X to embrace our community. So, as usual, this week we will have a topic to talk about, and that is going to be cryptographically secure hyperbridge cross-chain interoperability. I think that there are many aspects that we can break it down into about this topic, from cross-chain interoperability to security while cross-chain, and also we are taking a deep dive into Hyperbridge, a crypto economic coprocessor designed to be a cross-chain solution. So, with that being said, a warm welcome to our two speakers of today. First up, we have our familiar guy, Tin, developer relation engineer at OpenGuild. And our second special guest today is Seun. He is the founder of Polkadot Lab. So, hi guys, welcome.
Hey, happy.
Yeah, thank you for having me.
Yeah, so I think just a quick warm up, because today our topic is going to be, about cross-chain interoperability and security while doing cross-chain as well. So for you guys, you don't have to go like really deep into it, because I know that you're gonna have different parts to talk about. But in general, how do you think interoperability is important in Web3? Can I hear from Seun first?
Yeah, happy to go first. So, I mean, to maybe start with is the idea that like blockchains are they've shown themselves to be this programmable layer that can host like a variety of applications. It can host like you know AMMs for asset swaps, can host NFTs, can host money markets for lending, options, perpetuals, can even host non-financial applications as well. And if we then view these blockchains kind of as computers, then it stands to reason that it's there's more opportunities, and there's more the design space for applications is expanded when these computers can now talk to each other, especially because you can now have computers that are specialized and can do they can do things that are maybe more performant, and maybe also faster, maybe, or they're just hosting data that's just not feasible to host locally on whatever computer you're on, and being able to then securely communicate with these computers and be interoperable with these computers, being able to send them messages to tell them to do stuff and also request some information from them, I think is very powerful. I think that like today, if you're building an application on a blockchain, you essentially only have access to the data that's local to you on that blockchain. And maybe when we look at the AI boom, it turns out like data is everything, right? Like you can have applications, you can have programs, you can have algorithms, but ultimately they're useless if they don't have any, if they're very limited in the amount of data that they can access, right? And so interoperability expands the amount of data that on-chain applications have access to, and this really can only serve to enable new kinds of applications and new kinds of user experiences in Web3.
I see. So for Tin, I know that we have the trilemma blockchain, right? So there be like security and scalability, decentralization. So how about interoperability? Is it like a very important aspect in terms of your perspective?
Yeah, I think that from my point of view, yeah, actually, like Sean already like give a very great answer to the question already. But yeah, from my point of view, like we had a community call a few weeks ago about like cross-chain decentralized finance, and like we did learn that like um the application on top, especially decentralized finance on top of blockchain right now is has a lot of fragmentation issues, and then like cross-chain interoperability is like from my point of view definitely one thing that we need for like a future decentralized applications, because like even like in the traditional software development, when like you have like application like communicate with each other easily to like different kind of protocol, but like in the web 2 traditional software development, like those kind of things are just less, no, not just less, but like we have we have to give a trust to like a middleman, so we don't give any like we don't give we like user developer don't pay any attention to the trust problem. But like in the blockchain space, when like we already like try to build like a trustless environment to the blockchain technology, so I think like definitely for decentralized application be on top of it, if they want to communicate with each other, they also like definitely need a solution that is just free. So yeah.
Okay, I think that our topic today is going to be really interesting. And just going through briefly through the agenda, well, we're going to have two parts. So Tin's part, it's going to be understanding blockchain interoperability, cross-chain challenges, and also Polkadot share security solutions. And for second part, he will take us into a deep dive into Hyperbridge. So yeah, let's get right into our session today. Tin, I'll leave it to you.
Yeah, thank you, Pia. All right, so let's get started. First of all, so good morning, good afternoon, everyone, and thank you for like coming to the community call today. So we're gonna get started. And like I just give a very short introduction and explanation about the topic that we're gonna talk about. And then I'm gonna like give a mic to Sean, to explain to you guys about Hyperbridge, because I think like right now like the community member are very hype and want to learn about Hyperbridge. It's hype, right? So first about me, like I'm Tin and I'm the OpenGuild developer relation lead. On the other hand, I'm sort of a Polkadot blockchain academy Wi-Fi graduate and Polkadot SDK contributor. Meanwhile, I'm sort of working as a software engineer and I love to be back. So OpenGuild is a Web3 hub for like Polkadot enthusiasts in Southeast Asia region. So like we mainly focus on like building like hosting a lot of events. So like people who interested in Polkadot can join the community, can join our community, and then like go to the event, networking with other people, networking with other developers, so that they can roll their network pool. On the other hand, like we also like research and development, like we build a lot of like open source tool to help growing the community and also like the Polkadot ecosystem. So here's like a few photos of OpenGuild in the past few months. So like we already do a lot of things in the past few months. I think like 5 months. And then like, for example, we build a few tutorials in Rust and also in Substrate to help people learn about this technology. And on the other hand, like I also have this photo right here showcase our activities in the past few months as well. So for example, like we also like come to Sub-Zero in Thailand and we host a durian party in Malaysia just like a few weeks ago. Then we also like a community call and also have some offline workshop. Okay, so the next thing is about open contribution bounty, and open contribution bounty is already like run for a few weeks, and open contribution bounty is a great chance for you guys, to join the bounty, like take a topic and then contribute to it. So open contribution bounty is include 5 different check with the total prize pool up to like $20,000. So the first check gonna be subtrade cost. So like if you want to be we want to learn about subtrade, but on the other hand, you also like want to like earn from it, then like you can build the subtrade course for all the community member and also like all the people to learn about subtrade. And for the check two, we ecosystem open source documentation. So let's take example if Hyperbridge like have any like issue in like contributing to their like documentation. So like you guys can like contribute to Hyperbridge and submit that to OpenGuild to claim the bounty. That's what as well. On the other hand, like you also like can contribute to the Polkadot SDK or any like kind of parachain documentation if it's valid for the ecosystem. And you have like check 3 technical blog that like you can write blog posts, any kind of topic related to Polkadot and Polkadot ecosystem. Maybe like writing a blog post about Hyperbridge, because we also have that topic on our open contribution bounty GitHub repository. And check for would be like workshop technical activities that you're gonna build like technical activities or like just a small tutorial to guide people like about programming and also like Polkadot development. And like check file gonna be like open source contribution. So if you have any idea, you can like request for proposal and also like submit that to our community, and then like you can contribute back to that the proposal that you submitted, and then like claim the bounty. Okay, so like when I designed the slide for Hyperbridge, it's just like one statement come into my mind, which is like connect the 9 realms. I learned this from like a by force, which is not by force in Polkadot, but by force in the Norse mythology, as I remember. So yeah, if you watch like Marvel movies, you're gonna learn about it. So like Hyperbridge, connect the 9 realms. I just found it cool. Um, Okay, so just like flashing back a bit. So like our community, our OpenGuild community also like a contributor to Hyperbridge documentation on Polkadot Wiki. So if you want to learn more about Hyperbridge, you can like visit Polkadot Wiki and then like search for Hyperbridge and then like read some definition about Hyperbridge and learn more about it. On the other hand, like you can just focus on this community call, and then you will get any idea about Hyperbridge, because we also have a founder of Hyperbridge today in our community call. Okay, so blockchain interoperability, why does it matter? So as I mentioned at the beginning of the community call, which is about the fragmentation issues that we have in blockchain. So like, let's say like if you have like a multiple different blockchains out there, like chain A, chain B, chain C, chain D, each blockchain like they already build their like ecosystem of application, and also like they have their own market to the economic to the economic tokens. So in that way, let's create the liquidity for the whole blockchain, which is for chain A, which is liquidity A, and respectively, you also have liquidity B, liquidity C, and liquidity D. But the problem here is like this liquidity is like fragmented on each network. So if like I have one protocol that I want to support like two different blockchains or multi-chain, by the way, like I have like do like multi-chain deployment. So like I have like to deploy my application on chain A to use the liquidity of chain A, and then like, I have to like deploy the application again on the other blockchains to use the liquidity of the chain B or maybe the chain C. But the problem here is like all this liquidity is still fragmented. I just have my protocol to support that specific chain, but I doesn't have my liquidity share between or the change. So this when like interoperability like come to solve the problems. So why do we want like cross-chain decentralized finance? So um, I think like decentralized finance is a common problem when you want to think about why do you need this kind of cross-chain functionality. So as I mentioned, so like our liquidity is fragmented for the like on different blockchains, and how to solve it, then like you mine it like one protocol to offer the cross-chain functionality, and then to like merge all the liquidity of like all the blockchain together to become like one shared liquidity. So in that way, like when someone like build a protocol on chain A, they only have to focus on chain A, and then they can still use the liquidity of all the blockchains. So here's like um some like landscape of the cross-chain interoperability of the Polkadot ecosystem. So like you have XCMs as the standard a standard message format for like a person to like communicate with each other. On the other hand, you also have all the bridges, which is like external bridge that gonna link to the Polkadot ecosystem to like from outside. For example, like you can take like Snow Bridge as a bridge between like Ethereum and not between Ethereum and Polkadot, or you also like have like composable finance, which like stand in a middle for like Cosmos ecosystem and also like Polkadot ecosystem. But the problem here is, yeah, before coming to the problem, so like about the Polkadot native security, so we learned that like the parachain, the reason why like, when people decide to become a parachain or not is that Polkadot like, offer a native security feature, and security and scalability is in the core design Polkadot protocol in the day zero. And with the concept of like share validator set of the relay chain, native security is the core feature of the Polkadot system in day zero. So parachain doesn't have to build their own economic incentive and validator set to provide security. So in that way, they can just focus on the scalability and in the multi-chain network, and then they just scale up their blockchain without like worrying about all kinds of like security stuff. Different from like we can compare it with other solution, which is agent layer in in Ethereum. So agent layer also like offer like the active validations a layer to help the active validation service to like use something similar to set security, but it's not native in the protocol like Polkadot, but it's like go to like another like restacking functionality like become like another DeFi project. So roll up like communicate with like other like roll ups in the Polkadot communicate with the other. So there is a shared language, cross chain message, which is like CMs, and we also like have a diagram here. Like parachain one gonna send the SCM message to relay chain, and then relay chain they send SCM message. On the hand, like you also like have, I don't remember, but I think it's HRMB or VMB. But yeah, like you have like HRMB or something, that kind of protocol that help you like to like communicate between like parachain 1 and parachain 2 as well directly without like go to like relation. So it's XCM, but that does not apply to the outsider. So the problem is like the outsider, let's say like if I have like a Solana blockchain, which is like outside the Polkadot network. So like if like a Solana blockchain, you want like to transfer the asset from on a Solana blockchain to a Polkadot network, then the like the fundamental logic gonna be like you burn a token on Solana blockchain and then you mint a new token on Polkadot. But the problem here is like how you validate the state, because like these two blockchain is basically a state machine, and then like you don't receive a state, and then like you use the state to decide like whether the next state of the blockchain. So the state verification process is the important part of building a bridge. And we also gonna like learn that from Hyperbridge, how they gonna like manage this process and how to make it become like just less. And that's also the challenges of the current bridging technology that I just mentioned. So now we're going to deep dive into Hyperbridge. And Sean, are you ready?
Sure, I am. I can just share my screen. I have a few slides that we can just walk through.
Yeah, okay, that's awesome.
All right, give me a sec here. Says I have to quit and reopen Discord. Give me like 5 minutes, guys.
Okay. Yeah. Meanwhile, like if you have any questions that you want to ask Sean, like feel free to like give it here. And then we're gonna connect. We're gonna like collect and then like in the Q&A section later at the end of the
All right.
community.
We are back. All right. Let me know if you can see my screen. Can you guys see my screen?
Yeah, we can.
All right, awesome. So basically, Hyperbridge is what we describe as a coprocessor for interoperability, specifically verifiable interoperability. That's interoperability that's powered by cryptographic proofs. What's a coprocessor? What are these proofs? We'll get into all of that. First, let's understand this notion of verifiable interoperability. How can interoperability be verifiable? Well, we start off with the fact that blockchains, as we discussed earlier, are essentially isolated. They only have access to their own state, and this means applications that potentially want to access another blockchain state is just not able to do so. For instance, say an application wants to send a message to another application on another chain. If it needs to do this, then the application that's receiving this message needs to be able to authenticate that this message is indeed coming from, application A. And it's like when you sign a transaction, right? Like when you sign a transaction, then the blockchain is able to verify your signature and know that this transaction is coming from you and that you are authorized to do something with some account, right? You're authorized to spend some funds on your account, whether that's tokens, whether that's a native asset, whether that's to call an application function, whatever. So we need authorization, some kind of cryptographic authorization that tells us that this message is coming from this chain or this application. This authorization can be seen as this signature that either the application itself or the chain that hosts the application produces. Typically, it's the chain itself that produces this authorization. And this authorization is actually already well known. It's called the SPV protocol or the light client protocol or consensus proofs, whatever you want to call it, which is originally proposed by Satoshi himself. This was in the Bitcoin white paper, chapter 8 of the paper, where he says, if we want to allow Bitcoin to be used by more people, of the world, and we want it to be trustless, then people should be able to run a light client on their phone, and they don't have to run a full node or a miner, but they're still able to access the network. It's a completely permissionless and peer-to-peer network. There's no central server that can censor you. You just ask random nodes on the network, and then they can tell you stuff like what is the finalized chain. They can tell you, that if a block has been confirmed by other blocks in front of it, and that would be your finality proof, right? And then you can query like Merkle proofs of the transactions, right? And these two things will essentially be able to convince you that some transaction had taken place on Bitcoin. I'm not really going into depth here, but the general idea is that these proofs are actually very simplified, are called consensus and state proofs. Consensus tells us what is the finalized state. As we discussed earlier, blockchains are state machines. Every block has some commitment, or you can think of it as hash of the current state. It's called the state root. And if you have Merkle proofs that point to some storage item in the global state, so all your contracts, all your balances, everything is stored in this state object that is a Merkle tree, and you can essentially obtain Merkle proofs that can confirm what is the current state of your balances or the current state of your programs on chain. And so you can combine these state proofs, and you can combine them with these consensus proofs to tell us which is the finalized chain, in order to facilitate interoperability, right? So you can say, for instance, I'm going to reserve some part of the state or some program to be what is the message outbox. And then I can tell other contracts that want to send cross-chain messages to put their messages into that contract's storage or state, and we can then get state Merkle proofs of these messages, right? And like I was talking earlier, this is the section from the Bitcoin white paper where Satoshi describes sort of light client, the first light client protocol, essentially. So just to recap, SPV protocol, you need to verify the finalized state root using consensus proofs. In proof of stake, this would be signatures from the validator set. And for all intents and purposes, they sign the header, and the header contains the state root. And once you have this verified header, you can then get the messages and then the Merkle proofs of the messages. And then once you authenticate these messages, now we know these messages are indeed coming from the chain that we know about and we care about, and we can then execute the message. We can do whatever the message says. But the problem is that these two steps before we execute the message are just way too expensive, right? So as an example, if you have a validator set of over 1,000 validators and they're producing like, let's say 667 signatures that's needed for supermajority attestation of the finalized chain, then you have to verify 667 signatures. You're paying data costs for these signatures because you pay data costs for submitting transactions on chain. The Merkle proofs, are also a different issue, because if you are unfortunate that your blockchain has a lot of adoption and a lot of users, then you have what is called state bloat. So that means the state of your blockchain is very large, and that also means that the Merkle proofs of your blockchain will also be very large and very expensive to verify. So this is essentially why no one builds trustless bridges. This is why every single bridge that exists today, Layer 0, Wormhole, Axelar, what have you, they are all trusted, because trying to use the proofs that come from the source chain as the authorization, it's too expensive to verify, but it's cheap to verify, like multi-sig signatures, right? It's just one signature. I just have like 3 of my guys sign, and it's like 3 out of 5, and that's enough for us to authenticate that some messages should be executed. And so what we're trying to do at Hyperbridge is how we can solve this problem of this fact that these proofs are too expensive. And we can see here essentially that if we add more blockchains to the mix, we're just talking about here about just a single blockchain, but now imagine if we wanted to have a multi-chain bridge where there's multiple chains in the mix. We have these many proofs, and we need to be able to verify them very, very cheaply. So this is kind of a visualization of this problem, and maybe to go back a bit, there are some trustless bridges that exist today. In fact, there is the near Ethereum bridge. There is the I think Gnosis Ethereum bridge as well. There's also the Polkadot, now very recently Polkadot Ethereum bridge. Building trustless bridges that are sort of one-to-one is very, it's not entirely impossible. You can definitely get around these things, and you can make these things happen, but the problem is when you try to scale up, then you have so many proofs that it just becomes impossible to verify all of them. And so to do this proof verification, we introduced this idea of a coprocessor. And maybe just to recap what coprocessors are, because these are not like a blockchain specific thing. This is actually something that exists in everyday computing. Your phone has coprocessors for your cameras, for your gyrometer, for your accelerometer, all kinds of sensor processing that is independent of the CPU, right? Essentially, if we were to do the work that's required to process data from these sensors, then the CPU is just not equipped to do this very efficiently, right? And so people realize we should just design special hardware that can perform all the necessary computations in a very highly optimized manner. For instance, your GPUs as well, the process graphics, these are specialized coprocessors for specific tasks, right? And so if a blockchain is unable to do this proof verification, then it stands to reason that we should design some kind of a coprocessor for this blockchain that could do all this proof verification. And this blockchain can then receive what is the output of this, this verification and the proof that this verification was done correctly, right? Because if we don't have proofs, then essentially we've created an oracle, right? There's no way for us to detect when things go wrong. And we want to keep things permissionless and we want to keep things decentralized. So basically, cross-chain messages should be authenticated with these proofs, these consensus and state proofs, but they're too expensive. And so we need a way to verify it off-chain and present some sort of cheaper proof that this verification was done correctly. This off-chain layer, we can just see it as a coprocessor. And the sophisticated among you will say, well, isn't a snark a kind of a coprocessor? Yes, they are. But snarks don't really scale for interoperability, and we'll go into the reason why. Essentially, snarks, they impose what is known in the business as asymptotic slowdown. So essentially, if you have a program that probably runs in like 10 minutes, if you were to put it inside of a snark, then this program would run in, say, 100 to 1,000 minutes, right? Like, there is a slowdown that is incurred because of the expensive steps that need to certify the correct execution of a program, right? And this also translates to expensive proving costs that is eventually has to be passed down to users, right? So snarks are expensive, not just to prove, but also for end users as well. Snarks are very slow, which means that now you're waiting like a few hours for your cross-chain message to confirm. And this is something that's not really talked about, but the real reason snarks are being championed is that people think that blockchains, which are essentially decentralized network of nodes that are constantly executing the same block or the same piece of computation, is inefficient, and that a single person should do all the expensive work to execute a block, and then the rest of the network just simply verifies a cheap proof. Now, this sounds like it's a really good idea, but ultimately we've given control of the network to whoever is running these provers. They can essentially censor transactions, and no one can do anything because there's such a high barrier to create these proofs in the first place that essentially we've built a wall around this wall was supposed to be a wall, a permissionless guardian, like they say. So snarks are necessarily centralized because it's just more efficient that way. You can't have a network of people who are all who have very expensive hardware that only runs for like a few minutes because you're kind of rotating who should produce proofs. It just makes sense to have one person whose machine is just running all the time and producing all these different proofs, right? It's more efficient that way. It's just the same way like you can't decentralize AI training because it just doesn't make economic sense, right? You should just have one person do all the AI training, and that's it. And finally, is I think they lead to very, very subtle bugs. Like snarks are not really good at secure crossing bridging, and it's because crossing bridging is not a problem of it's not a cryptographic problem. It's a crypto economic problem, which is that you're trying to verify signatures from the validators who have staked. These signatures are actually they're what holds them to their stake. If these signatures are not available, then there's nothing that stops validators from misbehaving. And this is actually a known problem in proof of stake systems. It's also called the nothing at stake problem, which is this idea where if validators were to unstake, then they could essentially create this forked chain that could fool nodes of the network into following their own chain. And they just keep signing and double signing. Well, not really double signing anyways, because they're no longer part of the active set. But they sort of created this parallel reality that's not real. And if a full node hadn't been synced, past the point where they unstaked, then they wouldn't know that they were these validators were actually unstaked. They would just follow this fake chain, and then this is of course an attack on blockchain systems. And so essentially, snarks create this possibility for this kind of attack where essentially if you put the signatures of a consensus proof inside of a snark, then the snark actually allows you to compress this consensus proof into a much cheaper proof. And now we no longer have the original signatures, and this also means that we no longer have any risk of slashing. So validators could very, very easily create proofs of a fake chain and submit them on chain to light clients and essentially steal funds, and they would not be slashed for it. And so we should then probably look into an alternative design for coprocessors that don't have all of these different issues. And so let's actually go back to the original Bitcoin white paper where Satoshi was describing something. So maybe Satoshi didn't really know it at the time, but he was describing not just a light client protocol, but he was describing blockchains as verifiable computers, where he says, look, it's possible to verify any computation that's done by the network. It's just the case that Bitcoin only processes payments. But if you had a programmable blockchain, it's actually possible to verify that the programs that's on that blockchain are running correctly by simply looking at the block headers and looking at the consensus proof, right? So if you have a consensus proof and you have the headers, then you technically have proof of what the network is doing. You have proof of the outputs of all of the programs that's on chain. And so this is very, very revolutionary. It essentially means that we can replace a snark with actually a blockchain, all right? And so we have a blockchain in the middle, and this blockchain actually does all of the verification that's needed to authenticate messages from a single chain, and it produces the authentication that's needed for blockchains on the other side to receive messages from any chain. And this blockchain is really, it's using its consensus proofs, it's using its state proofs for this authorization. And it's also the case that this blockchain has consensus and state proofs that are optimized to be very, very cheap to verify, right? And we can see the relationship between any chain and the coprocessor is that we get the state root. Ultimately, that's what we care about. And this is verified by the signatures of the validator set. And then eventually we get the messages that are being sent out, and we get the Merkle proofs of these messages. So the coprocessor is aggregating these messages. It's putting them into its own Merkle tree, so that any chain can then receive the aggregated messages roots, which is its own Merkle tree. And this Merkle tree contains messages from multiple different chains, right? So essentially a single Merkle proof actually contains messages from multiple chains. And this is much more scalable. This is much more of course, cheaper to run than if you had to maintain a verifier for multiple chains. And ultimately, this is actually already what Polkadot does. So Polkadot is already doing this message aggregation. Whenever you send messages through HRMP, Polkadot's aggregating all its parachains, and it's aggregating all the messages, and it's distributing messages to all the different parachains. And so this is also what Hyperbridge is doing, but this time not for parachains, I think of I like to say that I think of Polkadot as this very strict father that says, oh look, you must follow my consensus, you must follow my I will check your state transition functions, you must make your transactions available to my relayers, my validators, so that we can audit what's going on. But for Hyperbridge, we don't really do all that. We just say, well, as long as you follow your own consensus rules, then we're able to do this aggregation for you, and we're able to also do this distribution. And so for the final part, which is hyperscalability, there's an issue actually with this aggregation, this coprocessor aggregation, which is that this coprocessor is a bottleneck essentially. Blockchains, they don't they don't really scale, unfortunately. I mean, we've seen this tons of times. If there's a lot of transactions, immediately fees go up, transformation, confirmation times go up. Especially if you want to aggregate messages, aggregate transactions from multiple blockchains, then how exactly is this going to scale, right? So this is where Polkadot comes in, and this is why we like to say that Hyperbridge is really only possible on Polkadot, which is that essentially we can parallelize Hyperbridge. Hyperbridge is a fully parallelizable process. You can run the Hyperbridge blockchain across multiple parachain slots. And you simply shard, right? When you say shard, you mean you share the work that it's doing across these different parachain slots. So instead of having one core do all of the work, you can say, well, okay, maybe one core should just do 2 chains, and maybe there's a lot of transactions coming from chain C, so let's just dedicate a core to this, and you can kind of just split up the work across these different cores. So all these different cores, they're all aggregating messages across all the different chains. And then ultimately, Polkadot's going to aggregate the messages root of all these different cores into its own consensus proof. So a single consensus proof actually contains all of the messages from all these different chains, so that any chain can still receive basically a single Merkle proof of all the messages that Hyperbridge has aggregated, which is now happening over multiple cores, but they don't really see it. They just see a single proof, right? So this is exactly how Hyperbridge is able to scale, but still keep costs low for users, and still keeps the ability to also scale to literally any chain as possible. Because at this time, I think we have over 50 cores, but theoretically, Polkadot could support over 100 parachain cores, and I think with Jam that goes up to 300. This means that Hyperbridge could potentially scale to more than 1,000, well over 1,000 blockchains concurrently being connected. And this is, of course, all theoretical in the future, but of course, we also have to build these things to be scalable, so that we're not caught unaware, right? Because that was one of the issues with Ethereum, which was that they built a system and they didn't really think about how it was going to scale. And that's just a problem that's currently haunting Ethereum today, with its L2 fragmentation and its lack of native interoperability between these L2s, because they're basically an afterthought. But in this way, Hyperbridge is literally future-proof, well into the future. And so that's basically the theoretical part of it. But concretely, what do developers who want to use Hyperbridge, what can they use it for? Well, Hyperbridge is basically a Polkadot parachain. And parachains have very fast finality, so which means messages that are aggregated by Hyperbridge, they can be delivered to the destination almost immediately. We're not waiting for any kind of proving time. Polkadot provides very high economic security, which is needed because remember, we're using Polkadot's validator signatures as the authorization for messages, and it must be very expensive to compromise these signatures, right? And this is kind of the highest economic security for any bridge today. And you can actually look at all the bridges on the market, none of them have economic security as high as Polkadot. Polkadot has these very cheap consensus proofs through Beefy, and we benefit from this concurrent design of Polkadot, which allows us to do this do this aggregation, and also potentially block re-execution for optimistic L2s that don't really have any proofs of their blocks, right? Hyperbridge allows for arbitrary message passing. So if you're building, if you want to build multi-chain applications, then you could essentially use Hyperbridge to pass messages across different chains. It has a very rich messaging protocol where essentially, because we're using proofs, we can actually tell if the message that you sent is unable to be executed, right? So If for whatever reason the message you send is unable to be delivered or executed correctly, maybe while it was executing the message, the contract reverts, we can tell. And we can tell you that your message is timed out, essentially, and we can prove to your message is timed out using proofs. And so this actually creates I think, one of the most safest cross-chain messaging protocols, on the market today, essentially, because you can actually know for a fact that either your message is going to be executed or you're going to get a timeout, and you can handle something. You can do something. You can revert whatever you initially did before sending a message, right? It can also be used to read on-chain state, and this is, I think, very powerful as well. For instance, there's a parachain on Kusama right now. I think it's the Region X parachain, and they're actually using Hyperbridge technology to read the core time chain so that they can then create a marketplace for core time, literally. And like I said, being able to access the state of other blockchains can only really lead to new kinds of applications and new kinds of user experiences. If the Region X parachain was unable to read the core time chain, then honestly Region X wouldn't exist, right? Because the core time chain doesn't have any contracts. And so if you want to create a marketplace for core time, you need to be able to access the metadata of core time. Like, what is this core time valid for? When was it issued? How long will it be issued for? So that we can properly then value these things on chain. And so being able to read state is, I think, one of the fundamental innovations or groundbreaking innovations Hyperbridge brings to market, because no other bridge solution has this. And so you will be able to say, for instance, I want to know the balance, the token balance of an address on some chain, and you can then do something with this data. You can then compute over this data. You can have applications that use the data for something. Or you can say, I want to know what is the value of some storage item in a contract. Maybe I want to know what's the price of a Uniswap pair on any chain, maybe BNB chain, and do something with this information. Maybe I want to query this information, periodically, so that I can then execute some trades. Honestly, the possibilities are endless. And Hyperbridge is basically live today on testnet. We're on Paseo testnet, and we're deployed to all the Sepolia chains. And you can start playing around with Hyperbridge already today if you're interested. I would have done a testnet demo, but we're currently in the middle of mainnet, so we've actually shut down some stuff that's probably critical. So unfortunately, maybe not today, definitely another time, or even better, when we launch on mainnet, we would do just a small mainnet demo. But that has been my presentation. I'm happy to take any questions.
Awesome. Yeah, thank you for the presentation. Like that's really like unexpected, because like I actually prepared a slide to ask you a bunch of questions, but I think like you already answered all of them. But like from my personal view, also I have a few questions as well. So as I understand, so Hyperbridge is actually a core processor that is like core processor as a parachain, and then it is like standing in between of the other blockchain as well. Am I right?
Yep.
Yeah, so let's say like, are there any chance that like a Hyperbridge can like tamper the proof that they're gonna receive from other blockchain, because like now it's also like become like another kind of a middleman, right?
Yeah, so Hyperbridge, first off, is a blockchain. Blockchains are decentralized. We can have a decentralized network of collators. We can have a decentralized network of nodes. So no one essentially controls this blockchain. So it's not really a middleman, if that makes sense.
Yeah, but what I mean is like let's say like a set of let's say like a set of the stakeholder in the Hyperbridge network, they're gonna decide to like tamper the proof of like tamper the state that they're gonna receive from other blockchain. And are there any chance that like they can mutate this that like other blockchain state when they receive it?
Yes, they can't do this, unfortunately. Essentially, what that would require would be to maybe do a governance proposal. Maybe you try to do a vote on a governance proposal to mutate or to insert some malicious fake state of a blockchain. I mean, obviously, the governance, everyone would see this and they would vote against this, right? Even then, so is that like we don't actually allow for governance to have that kind of control over the Hyperbridge blockchain. There are some things that governance just can't do, which is you can't arbitrarily mutate Hyperbridge's own state.
I see. So on the other hand, like when I read the Hyperbridge documentation, I also like found the concept of relayer. So can you help me like to explain like what is the role of the relayer in the core processor model?
Right. So Hyperbridge basically is a blockchain, and so it doesn't have any physical way to collect proofs and to distribute these proofs to wherever they need to go to. You know, it's very limited in its abilities. All it can really do, honestly, is just to verify proofs. And so we need relayers who are going to collect these proofs from one chain and submit them to Hyperbridge. And once Hyperbridge, does the verification and does the aggregation, then the relayers collect all the proofs from Hyperbridge and then deliver them finally to their destination chain. And so a relayer is really a permissionless piece of software that does this proof collection and proof submission. Anyone can run a relayer. You don't need to stake. You don't need to have any special permissions because you really can't misbehave. If you try to submit invalid proofs to whether Hyperbridge or the destination chain, these proofs would fail and nothing would happen.
I see, I see. So like we have a few questions from our audience as well. So let's see. The first question is gonna be like seeing like Polkadot is already has its own interoperability, but like the ECMs. So why does we need Hyperbridge here? Is that to bridge some external chain from outside to Polkadot?
Yeah, I mean XCM is pretty limited. It doesn't allow you to read state, doesn't allow you to communicate with really any blockchain. I don't think it was designed to be an option, this chain agnostic interoperability solution. And so Hyperbridge really is a more chain agnostic solution for interoperability, and not just for parachains, but really for any chain to communicate with each other.
And you mentioned like one blockchain can read state of other blockchain like for Hyperbridge. How does that actually work?
So this is actually a really cool byproduct of the fact that Hyperbridge is aggregating the verified state roots of all of the different chains. So relayers could not only send us state proofs of cross-chain messages that need to be delivered, but they could also just send us arbitrary state proofs of arbitrary parts of the state that were maybe requested by contracts that need it, right? So they would essentially, a contract would say, hey, look, I want to, for instance, I want to know the balance of this address on maybe Ethereum. Give me the value of it, and what would happen is that a relayer would get the state proof of the balance of that user of that account from Ethereum, and then submit that to Hyperbridge. Now Hyperbridge already knows the state root and is able to then verify that state proof, package it into a message that can then be sent back to the original contract requesting for that proof. And they'll just get the raw data, right? They'll just get the raw value of that item that's in state. They will decode it and then extract whatever information they want to extract.
Yeah, awesome answer. And also like I think we have Snowbridge as well. Is there a difference between like Hyperbridge and Snowbridge? And can we bridge like Ethereum with Polkadot for Hyperbridge?
Yeah, no. So I think Snowbridge is basically, like I said, this is one-to-one bridge, and Hyperbridge is this more scalable multi-chain bridge. Hyperbridge is also bridged to Ethereum L1. It's bridged to the L2s as well, so you can have optimism, you can communicate with Base, Arbitrum, and really any kind of OP stack chain. We also support BNB chain. There's plans to support Polygon as well. We're going by the order of DeFi TVL, so essentially very chains that have active DeFi ecosystems. And I think another thing that's Hyperbridge is different from Snowbridge, or another way that Hyperbridge is different from Snowbridge, is that Hyperbridge has its own messaging protocol, which gives you these abilities that I think Snowbridge just doesn't provide, which is this ability to send messages that can time out or to request state from any chain. I don't think you can do this with Snowbridge. So Hyperbridge is fundamentally messaging layer. I think Snowbridge really at the moment only provides token bridging. And Hyperbridge could also be a solution for parachains to bridge to Ethereum if they wanted to, maybe receive assets from Ethereum, want to tap into Ethereum users. You could definitely use Hyperbridge here. You could, receive assets, mint them on your chain, send them back to Ethereum, or bringing even stuff other than assets like NFTs, or bringing arbitrary data. Honestly.
I see. I see. Yeah, as like as a researcher, like I also like learn about like ISMB, and I believe like that like protocol is like bring a lot of like it's improve a lot of like developer experience of for like substrate builders, or like also like other blockchain builders, when like you it's similar to like SCM, right? And then like you just do like transfer to like one protocol instead of like trying to do multiple bridge if you just want to send the asset to other blockchains.
Yeah.
Okay. Right. And like during the anyway, like how many like team members that you have in like Polytype Labs at this moment?
Yeah, so it's myself and my co-founder David. We're the only ones who are full-time. We have a few like interns and stuff, but Substrate, the stuff that we're working on is like super cutting edge. There's just not a lot of people who are actually able to contribute to Hyperbridge. I think eventually people will catch up, and we'll start to hire more people.
Yeah, and so like with the team size, with that team size, so like, do you have any like challenges and like blockers like during the development of Hyperbridge at this moment?
Yeah, for us, it's like managing it's like managing the Polkadot SDK and all of its upgrades. I think there's now a stable release of Polkadot SDK, so I think that should make things much easier. But other than that, I think Polkadot SDK has really, really great developer experience. Our stack is entirely in Rust. We write Rust on chain. We write Rust for the node. We write Rust for our relayer. We also have like SDKs for the browser, which are actually also written on Rust. So it's a blessing to be able to just use a single language for everything.
Yeah, yeah. I think I can understand your plan, like in the part of like upgrading the Polkadot SDK, because like today just like upgrade like from 1.8 to like 1.14, which is like like 7 version upgrade.
Yeah, and there's also no like there's no like proper versioning system in Polkadot SDK. Whenever they make a new release, everybody's like everything is broken. There's no backwards compatibility, which is really, really bad in my opinion. Someone needs to fix this.
Yeah. Also, like when we like the mainnet launch, I think like many of us like right here, we're really curious about that because like right now it's on testnet. So when will be the mainnet?
Right. So mainnet's kind of dependent on our kind of new website, new application. Technically, everything's ready. We're fully audited. We've gone through test nets, iterations, and we know that everything works. It's just building the user-facing portions of this that's left, and it turns out that's actually a bit harder than writing state proofs. We're hoping to launch in September.
Okay, yeah, we look into that. Also, related to launch, so like when I checked the website of Hyperbridge, I found out like we have like the product powered by Hyperbridge, and right now there's only like gateway is like review to the community. So how about like the other three? Like, do you have any plan for that?
Yeah, we're working with parachains first off, because parachains, they just don't have a lot of bridges or bridging technology, especially because of they don't maybe they don't have the EVM where like maybe Hyperlane or maybe like Wormhole could deploy their contracts to. And so we're working with Bifrost, we're working the hydration to bring Hyperbridge to their products. Of course, there will be official announcements to this effect once we're on mainnet.
Yeah, awesome. The other thing is that I think like from the community call today, like you could bring a lot of inspiration to like audience who listening to this community call, like with yeah, like your broad knowledge. But like I think that we miss a part that like for yourself to introduce about your background. So like your yeah, like your founding story. So I think like even myself, like I really want to hear about like more about you, and also like what is the founding story of like when for you, for of like the Polytype Labs and also Hyperbridge. So it would be great if you can share a bit about that.
Yeah, for sure. So I mean, I've been writing code for like the past, I guess, 9 years now. I dropped out of college to build software way back in the day. I think it was around 2017 when my coworkers introduced me to like Bitcoin, and I was asking them, okay, what does it do? Well, you just buy it and you hold it, and it goes up in price. Of course I thought this was some sort of a scam, some sort of MLM scheme. I'm obviously not going to do this. But I think around that year, Bitcoin actually crossed $1,000, and it just didn't mean anything to me, right? I just think I had to like look into what exactly Bitcoin was, and why is it valued so much? Maybe I'm missing something here. And that's when I discovered it was actually this cryptographic decentralized solution for basically permissionless money. And I thought that this was going to be very important infrastructure, especially because like we live in a world where there's now walls around the financial system. It's not easy for people to move money around, and so some people are being actively censored actually in the global financial space. So Bitcoin was essentially, um, I guess, a weapon to sort of remove these restrictions, and it's an unstoppable weapon as well. Like it's literally cannot be taken down, cannot be controlled. This was very inspiring for me. I knew that I wanted to contribute to the space somehow. I after picking up Bitcoin, I picked up Ethereum as well because that's just it's an obvious next best thing. Once you understand unstoppable money, then you get like programmable unstoppable money, which is Ethereum. And I was kind of doing some Ethereum open source stuff back in the day, and I just kind of like landed on Parity's doorstep, because Parity is also very big on the open source community for Ethereum, and they kind of saw what I was doing, and so they just gave me an offer to come work for Parity and continue to do the open source Ethereum stuff that I was already doing, right? So I worked at Parity for like 3 years. I worked on Ethereum initially, but then eventually Parity moved on from Ethereum and started working full time on Polkadot and Substrate. And I thought that was interesting. I hadn't really dug deep into the Substrate stack or the Polkadot stack. Really, I was just kind of kind of being a zombie and just working on whatever needed to be worked on. I didn't have this like full um, vision of the project, and I think that's also something that happens in very large companies, is that people can just actually keep doing stuff without actually knowing what the full vision is. And so after Polkadot launched, I actually decided to leave Parity so that I can maybe just take a step back and kind of understand what is the place of the product that we just built, which is Polkadot. What is its place in the broader crypto industry and crypto community? And for me at that time, I realized that interoperability was like something that's still very much unsolved, that we had solved, and we could then share with the rest of the blockchain industry. And so I was pretty interested in building bridges. I think Composable was interested also in building bridges, and it was just a natural collaboration there. I joined Composable to lead their IBC research and development, where we would essentially implement the Cosmos IBC protocol, put that on a parachain, and now a parachain would be able to talk to any Cosmos chain. Very fun project. Learned a lot from it. Learned, for instance, that the IBC is just not going to scale, unfortunately, and that we would need things like shared security, things that we would need more simplified protocols for communication, for developers to easily access the multi-chain in a secure manner. And that's all of that just led to starting Hyperbridge and then starting Polkadot Labs to build out Hyperbridge.
Oh, that's a nice, awesome story. So I can say like you're a very like OG member of like Polkadot, and also like a very OG member of blockchain, a whole blockchain space.
Yeah, it's been like 3 cycles now for sure.
Okay. Yeah, and I think like that's also like wrap up for our community call today. And yeah, thank you, Sean, for like coming to our community call. And that's like a great presentation. I learned a lot from it. And like we hope like good luck to your like upcoming production launch, and like our community gonna like keep an eye on that. And like also hope that we can have a future community call with you when like maybe like a production launch, who knows. And yeah, like thank you for coming to our community call today. And yeah,
Yeah, thank you for having me. It's really great to be here, and definitely would love to come back and talk about Hyperbridge when it's on mainnet. Yeah.
okay. And yeah, thank you everyone, and that's also a wrap up for our community call. And good night.
Bye, everyone.